Okay, welcome to Linear Modeling Day 2. And today we're just going to do best fit lines on the graphing calculator. So a best fit line is a line that follows the trend of a set of points. And a linear regression is when we want to find a best fit line for a set of data, we use this feature on the calculator called a linear regression. We've actually done this already. And then a linear model is what we call an equation of a line that represents real-world problems. To find a linear model, we use the linear regression on the calculator, but first we need to make sure that the data looks like a line when we graph it. Okay, so let's start by crossing off the second set of data. We don't need that one. We're just going to do the year and the price, the first set of data. So cross off the second. Okay, so let's start by entering our data into the table feature. So we did this the other day. If only I could zoom in and get the whole thing. Why are you not zooming out? Okay, so we're going to start by going to Stat and then hit Enter on Edit. And then we're going to clear our lists. So remember, go up, hit Clear, hit Enter, and then go over to List 1, hit Clear, and Enter. Okay, so now we're ready to write our two lists. So actually, before we do that, we're going to call 2000 year 0, and we're going to call 2001 year 1, and 2002 year 2, and 2003 year 3, and 2004 year 4. Okay, just to make our lives easier later. Okay, so let's get those in. So in list 1, we're going to have 0, enter 1, enter 2, enter 3, enter 4, enter. And let's get the appropriate Y values in list 2. So that's going to be 5,784, enter. 6,810, enter. 8,237, enter. 9,660, enter. And 10,984, enter. And then to find the linear regression, we're going to go, let's do that. Hit Stat, and then hit the right arrow to Calc, and then we go down to Option 4, Linear Regression. And then you're going to go all the way down to Calculate and hit Enter. And here we go. So we need the A and the B to write our equation. Okay, so write your linear model. It's going to be y equals ax plus b. So y equals 1,325x plus 5,645. That's our model. Okay, and we're actually going to skip part A for now. All right, so part C says, is it reasonable in 1999 for the car to cost $4,200? So where are we going to plug that in? Well, 4,200 is the price, which is the Y. So we're going to plug that in for Y. And then 1999 would be the year. So that would be for X. But let's talk about this. What would 1999 really be in terms of these numbers? So wouldn't 1999 be 1 year before 2000? So what number is right before 0? -1. So we're going to plug in X as -1 and see if we end up with something close to 4,200. Okay, so let's do it. Let's actually just do the right-hand side. 1,325 times -1 plus 5,645. Let's see what we get. So 1,325 times negative 1 plus 5,645. You get about 4,320. So they're saying, does that seem reasonable? That's pretty close to this. So I would say yes, that's pretty reasonable. Okay, so number 2 and 3 are the same thing. So feel free to pause the video, try it, and check, or just do it with me. Okay, so letter A, define your variables. Let's have the US be X and the European size be Y. Okay, so that's define your variables. Make a scatter plot. Is a linear model reasonable? We're going to skip that. Okay, so we're going to jump straight to write the linear model. So we're going to go back, make our list, and do all of that fun stuff. So stat, hit enter on edit, and then we're going to go up, clear, enter, and then go over, clear, enter. All right, and then we're just going to type in our list 1 and list 2. So list 1 is all the US sizes, the X's. So 1, 3, 5, 7, 9, 11. And then list 2 is the Y's, which is the European size. 31, 34, 36, 39, 41, and 44. Okay, and then we need to make the model, which is the linear regression. So stat, right arrow to calc, down to option 4, and then all the way down to calculate, enter. And there it is, y equals ax plus b. So we have y equals 1.27x plus 29.87. And I'm just rounding to the nearest hundredth on all these. All right, D says, find the European equivalent of a US size 8. So US size 8 is X. So we're going to have to plug in X to be 8 and see what we get for Y. Okay, so we're going to do 1.27 times 8 plus 29.87. We're going to use our model to get Y. So on your calculator, 1.27 times 8 plus 29.87. So the European equivalent would be a 40.03, so I would say about a 40. And that actually lines up perfect with our data. An 8 would be about a 40, so this was pretty good. All right, last one, same exact thing. So calories is X, fat is Y, that's defining your variables. And then we're going to develop a linear model. So in the, go to your list and type all that good data in again. All right, so yeah, you're probably going to want to pause this because you don't want to hear me typing in all the numbers again. But if you do, here you go. So stat edit, hit enter. And then we're going to clear list 1, and we're going to clear enter list 2, and we're going to type in our data. So the X's, 720, 530, 510, 500, 305, 410, 440, 320, and 598. And then list 2 is the Y, 46, 30, 27, 26, 13, 20, 25, 13, and 26. And then to get the linear regression, we go to stat, right arrow to calc, down to option 4, and then we go down to calculate. And there it is, y equals ax plus b. So this one's going to be y equals 0.07x minus 9.27. Okay, and then C says, how much fat if it's 330 calories, well, calories is X. So we're going to plug that into X and see what we get for Y. Okay, so in the calculator, Y equals 0.07 times 330 minus 9.27. And that will be our answer. You just got to plug it into the right thing. So go back to the calculate screen, 0.07 times 330 minus 9.27. And you get about 13.83 grams of fat. All right, thank you guys for watching. That's it.